Falcon 9, but it will have full and rapid reusability. So the crazy thing is that if things go as according to plan, we'll have...
For the first time in history, a rocket may have chased something from another star. Rumors say a Falcon 9 silently launched toward the interstellar comet 3I Atlas, carrying secret probes, a possible tracking beacon, and maybe even experimental technology. At the same time, Earth's magnetic field spiked, and its trajectory echoes ancient monuments. Was this science, military strategy, or something we can't yet explain? Let's discover. The attempt that shook the space community, an unscheduled Falcon 9 launch, may have been aimed at something no rocket in history has ever targeted before, an object from another star. According to a growing body of whispers in the space community, SpaceX quietly sent a mission to intercept 3I Atlas, the interstellar comet discovered this summer. No press release, no live stream, just a Falcon 9 lifting off under a veil of secrecy, carrying a classified payload that some say included experimental microprobes, a possible tracking beacon, or even a directed energy system. At the very same time, Earth's magnetic field registered a strange and sudden spike, as if something powerful had interacted with the planet's protective shield. If true, this isn't just another space launch. It would mean humanity has, for the first time, actively chased down something from beyond our solar system. Could this really have happened? Did Falcon 9 just brush against an object born around another star? And if so, what did it find? The rumors trace a dramatic timeline. On July 1st, 2025, astronomers with the Atlas survey in Chile spotted a fast-moving comet, quickly identified as the third interstellar visitor ever discovered. Its speed alone told the story. This was no ordinary comet bound to the sun, but a traveler from deep space, flying at more than 130,000 miles per hour and set to accelerate to over 150,000 as it approached perihelion. Within weeks of the announcement, something unusual happened. Notices to airmen and mariners, known as NOTAMs, were quietly issued, blocking off areas of ocean and airspace typically used for rocket recovery. Online observers flagged what looked like a Falcon 9 launch window, but there was no public schedule. No webcast followed, just silence. And then, in the same window that an intercept with Atlas might have been attempted, magnetometer readings on Earth picked up an unexpected disturbance in the planet's magnetic shield. The claims that followed were extraordinary. Some alleged the Falcon 9 carried microprobes small enough to pass through Atlas's coma, that glowing envelope of dust and gas surrounding the nucleus, in an attempt to scoop up grains of matter older than Earth itself. Others suggest a tiny beacon may have been deployed, essentially a spaceborne tracker, to allow telescopes worldwide to lock onto Atlas's path with unprecedented accuracy. The most dramatic claim is that the mission wasn't about touching the comet at all, but about firing experimental beams, lasers or particle streams at a body moving faster than anything humanity has ever tried to track, a possible rehearsal for a planetary defense scenario. Every one of these possibilities would be unprecedented. If probes truly grazed the coma, we might already hold the first material sample from another star system. If a beacon was deployed, it would mark the beginning of active interstellar engagement. And if directed energy was tested, that would suggest governments are already preparing for threats that don't come from our own solar system. Yet, all of these remain unverified. Still, the magnetosphere spike is what lends the story its most mysterious twist. Earth's magnetic shield is highly sensitive to energy events, and the timing of this anomaly matched the suspected intercept window almost perfectly. To believers, that synchronicity is too sharp to dismiss as coincidence. Could an experimental transmission aimed at Atlas have left a detectable ripple in our planet's magnetic field? Scientists point out that natural solar activity can also cause disturbances, but skeptics argue that the coincidence is difficult to ignore. If it was deliberate, this would be the first time an interstellar object left an electromagnetic footprint on Earth's shield. The human side of the story makes it even more intriguing. Amateur astronomers on space forums swapped screenshots of odd flight restrictions over the Atlantic. A handful of radio enthusiasts claim to have picked up chatter in frequencies they normally associate with rocket telemetry, only to hear it stop abruptly. Meanwhile, a few archaeoastronomers, researchers who study ancient sites and their astronomical alignments, highlighted something chilling. Atlas's entry angle appeared to match alignments at Machu Picchu and Göbekli Tepe, structures built thousands of years apart, but both designed to track celestial events with precision. Defense analysts chimed in too, noting how the mission, if real, could double as a test of military readiness against fast-moving threats. Across disciplines, from backyard stargazers to historians to military observers, the whispers converged into one compelling narrative. Something unusual happened in the skies above. If even one of these details is true, it means humanity crossed a threshold. Either we just attempted to touch an interstellar comet, or we watched a classified defense test hidden inside the perfect cover story of scientific exploration. Which is it? That is the real mystery. And it's what gives this rumor its staying power, because the stakes could not be higher. Imagine holding in your hand a dust grain formed around a different star billions of years ago, untouched since before Earth even existed. Imagine tracking a comet so precisely that for the first time in history, we could predict its path not just for months, but potentially years into the future, opening the door to intercepting other objects before they arrive. Or imagine governments already wielding directed energy systems powerful enough to reach across space, systems designed not just to communicate, but to protect Earth from the next interstellar intruder. Each possibility is staggering and would mark a turning point in our species' relationship with the cosmos. Yet, we must be clear, none of this has been officially confirmed. SpaceX has said nothing. NASA has acknowledged Atlas as a scientific marvel, but has made no mention of an attempted intercept. The United States Space Force remains characteristically silent on classified launches. That silence itself fuels speculation, but it also reminds us to keep skepticism alive. Extraordinary claims demand extraordinary evidence, and so far, all we have are fragments. So what did we really witness? Context behind the cosmic visitor. Something extraordinary has just entered our solar system, and it is unlike anything we have ever tracked before. Astronomers have confirmed the arrival of an object they are calling 3I, Atlas, and it is only the third time in recorded history that we have identified something that came from another star and passed through our cosmic backyard. The shock is not only in its arrival, but in how fresh and unaltered this visitor seems to be, as if it has been frozen in deep space for billions of years and is only now revealing itself. How rare is it to catch an interstellar traveler this early in its journey? Could this object contain materials or isotopes that do not even exist inside our own solar system? And if scientists are right about its size and speed, what would happen if something like this were ever on a collision course with Earth? 3I. Atlas was first detected in early July of 2025 by the Asteroid Terrestrial Impact Last Alert System, a network of robotic telescopes designed to spot potentially hazardous objects. Its path was quickly confirmed by observatories across the globe, and what they found stunned the astronomical community. The orbit calculations showed that it was moving far too fast to be bound to the Sun's gravity, a signature that immediately flagged it as interstellar. That placed it in the same rare category as the first two confirmed interstellar visitors, the elongated Oumuamua, discovered in 2017, and the icy comet Borisov, spotted in 2019. Early estimates suggest that 3I Atlas measures somewhere between 5 and 10 kilometers across, making it larger than Borisov and significantly more massive than the pancake-shaped Oumuamua. Telescopes have revealed a brilliant tail of gas and dust streaming behind it, evidence of volatile materials boiling off as the object approaches the inner solar system. Unlike most comets that have circled our sun many times and carry chemical fingerprints of repeated heating, this object likely formed around another star and has traveled for untold millions of years through interstellar space, preserving a pristine sample of another planetary system. Scientists are especially excited because such an untouched body could carry isotopes and chemical ratios that differ from anything in our own neighborhood. Carbon chains, oxygen isotopes, and even microscopic grains of pre-solar dust could tell us how other star systems build planets and whether life-forming ingredients are common in the galaxy. Some researchers speculate that studying a piece of 3IATLAS, even from afar, could reveal clues about how the Milky Way recycles material from dying stars into new worlds. Others wonder whether unusual ratios of heavy elements might betray a history of cosmic cataclysms, such as nearby supernovae or rare stellar collisions, in the system it came from. These are not idle fantasies. Previous studies of Oumuamua and Borisov showed unexpected mixtures of gases and dust that forced scientists to rewrite their models of comet formation. The excitement around 3IATLAS is amplified by the sheer difficulty of getting anywhere near it. Objects arriving from outside the solar system travel at enormous speeds relative to Earth. Current calculations place 3I Atlas on a hyperbolic trajectory, moving at dozens of kilometers per second, which means that any spacecraft hoping to rendezvous would need incredible velocity just to match its path. Traditional missions rely on gravity assists, slingshot maneuvers around planets to build speed, but even with clever planning, it takes years to design and launch such a mission. That is why the rumor of a Falcon 9 attempting an intercept raised so many eyebrows. SpaceX's Falcon 9 is a powerful workhorse for placing satellites and cargo into Earth orbit or delivering payloads to the Moon. But it is not built to chase an object tearing through the solar system at interstellar speeds. Without a specialized upper stage or nuclear propulsion, a Falcon 9 cannot hope to overtake such a target unless it was carrying some experimental technology that the public has never seen. This technological mismatch is exactly what made the alleged mission both thrilling and suspect. To even graze the coma of 3I Atlas, a spacecraft would need to accelerate to a velocity far beyond what chemical rockets can provide in a single launch. Engineers would need to consider multi-stage maneuvers, gravitational boosts, or advanced propulsion concepts like solar sails or ion drives, none of which fit within the usual Falcon 9 manifest. If, as the rumors claim, a stealth mission attempted a flyby to sample dust or tag the object with a beacon, it would imply either secret hardware capable of unprecedented performance or a creative trajectory that somehow exploited the object's own motion for a brief encounter. Could a rapid launch, small probe strategy have given mission planners a slim but real chance to collect data as the object passed through the inner system? The possibility is tantalizing, though it remains deeply speculative. Beyond the excitement of scientific discovery lies a more sobering motivation: planetary defense. Interstellar objects are not bound by the stable orbits of planets and comets that we have catalogued for decades. Their paths can take them directly across the plane of the solar system with little warning. A body even a few kilometers wide carries enough energy to cause planet-wide devastation if it were on an impact course. While 3I Atlas is not projected to hit anything in our system, its arrival is a reminder that the universe does not schedule threats on our terms. Could humanity one day face a rogue object arriving with only weeks of notice, too fast for traditional deflection methods? The question is not academic, and each interstellar visitor gives scientists a priceless chance to refine their models and prepare strategies for detection and response. All of these factors, the pristine chemistry, the extreme velocity, the limitations of our current launch technology, and the potential threat to Earth, combine to make 3I Atlas one of the most important astronomical discoveries of the decade. Whether or not a Falcon 9 truly attempted an intercept, the mere rumor highlights how urgently scientists and engineers dream of reaching such an object before it disappears forever into the dark. Ancient clues, modern stakes. To determine whether Falcon 9 truly attempted to intercept 3I Atlas, we need to examine how rocket launches are normally verified. SpaceX routinely publishes launch manifests, mission schedules, and live feeds, though there are exceptions for classified payloads where information is withheld. Even in these cases, Independent observers often detect activity through notices to airmen and mariners, NOTAMs, that restrict airspace and maritime zones during launches. Amateur radar operators and optical trackers frequently record telemetry, while hobbyist astronomers use orbital prediction software to capture trajectories. In the case of the alleged Atlas intercept, no public manifest, telemetry, or orbital data confirms a Falcon 9 launch specifically aimed at the interstellar comet. That absence does not constitute proof that no mission occurred, but it does mean that extraordinary claims require extraordinary evidence. What would settle this? Ideally, we would see a verified launch window with orbital insertion parameters aligned with ATLAS's trajectory, follow-up tracking data confirming a probe or beacon along the comet's path, or credible confirmation from a reliable source or whistleblower with direct access to mission details. Until then, we are left weighing rumor against the standard mechanisms of launch verification. The claim about a simultaneous magnetosphere spike is equally intriguing, but requires careful scrutiny. According to the rumors, Earth's magnetic field registered an anomaly precisely during the alleged intercept, hinting at a directed energy experiment aimed at the comet. Geomagnetic data are monitored globally, with indices such as the KP index and dense networks of magnetometers continuously measure local field variations. These systems routinely record fluctuations caused by natural events like solar flares or coronal mass ejections, which can produce sharp spikes in the data indistinguishable from short-term human activity without detailed correlation. To attribute such an event to a rocket-launched experiment, scientists would need synchronous telemetry from the spacecraft, corroborating readings from multiple observatories, and evidence that the signal's signature differs from solar-driven disturbances. Without this, the simplest explanation remains natural solar activity, instrument error, or timing coincidence. This is not to dismiss the anomaly outright, but to emphasize that magnetospheric spikes alone cannot confirm a human-made interaction. Another element of the rumor involves ancient alignments. It has been suggested that 3IATLAS's entry angle echoes astronomical sightlines at Machu Picchu in Peru and Göbekli Tepe in modern-day Turkey. On the surface, this is visually compelling, but there are several technical counters to consider. First, precession. The gradual shift of the Earth's rotational axis causes stars to drift relative to the planet over millennia, meaning that sightlines built thousands of years ago do not precisely point to the same star positions today. Second, with thousands of ancient sites around the world, many of which incorporate astronomical alignments, some coincidence is statistically inevitable. To assess the claim rigorously, we would need peer-reviewed archaeoastronomy studies, precise dating of the structure's construction and intended sightlines, and Monte Carlo simulations to evaluate whether such alignments could arise by chance alone. Only then can we separate meaningful pattern from coincidental geometry. The final extraordinary claim involves a classified military payload, potentially aimed at planetary defense or direct interaction with the comet. Falcon 9 frequently carries national security payloads, including reconnaissance satellites and technology demonstrations, which are sometimes withheld from the public. However, the distinction between classified and comet-specific intercept missions is significant. A true attempt to reach or influence an interstellar object would likely require extensive coordination under international law, including the Outer Space Treaty, which governs peaceful use of space and prohibits harmful interference with celestial bodies. Achieving even a minor maneuver in space to tag or sample Atlas would demand careful planning and cooperation with other agencies, making it improbable that a secret intercept could be entirely concealed. A more plausible explanation is that a classified payload coincidentally launched near the comet's trajectory, and confirmation bias led observers to link it to ATLAS. Extraordinary interpretations often emerge when multiple independent threads overlap in time, but alternative explanations are usually simpler and more consistent with existing evidence. So, who can provide decisive proof? The strongest evidence would include official telemetry from the Falcon 9 launch, showing a trajectory consistent with 3 IATLAS, imagery of any deployed probes or beacons, or peer-reviewed publications verifying sample collection or signal experiments. Additional verification could come from mission briefings or statements by credible personnel with direct access to classified operations, although such disclosures are understandably rare. Experts in orbital mechanics could analyze trajectory feasibility, while planetary defense officers could clarify whether such a maneuver is plausible under current technology. Magnetospheric physicists could assess whether a spike could originate from human-made sources, and archaeoastronomers could test the alignment claims rigorously. Taken together, these investigations show how difficult it is to separate rumor from fact. A Falcon 9 launch may have occurred. A magnetospheric anomaly may have coincided with an intercept window. Ancient monuments may appear aligned with Atlas's path, and classified payloads may have flown. Yet, none of these factors, individually or in combination, conclusively prove that humanity has already engaged an interstellar comet. They point instead to areas for further investigation and underscore the need for careful, evidence-based analysis before accepting claims that could reshape our understanding of space exploration and planetary defense. The extraordinary potential of 3I Atlas is undeniable, but confirming what happened requires more than coincidental timing and dramatic speculation. It requires transparent, verifiable data and rigorous scientific scrutiny. Thanks for watching. If you enjoyed this, don't forget to like, comment, and subscribe. Click the next video for more exciting content.